In this section, we're going to deal with models and applications, which is basically word problems. So we're going to start by writing some verbal expressions or phrases into expressions or equations. So basically taking the words and turning them into a math expression or equation using addition, subtraction, multiplication, or division. So in this first one, it says one number exceeds another by a. Well, first of all, exceeds means it's more than or goes above. Well, that should tell you that we're going to be adding here. And then it says one number. We don't know what that number is, so we're going to assign a variable to it. So we're going to just call it X. You could call it Y or B or any variable. And so it says one number exceeds another by A. You're going to have X plus A. The next one, twice a number, would just be 2 times that number that we still assign a variable to. So I'm going to call it X again. Next, we have one number is A more than another number. When you see the word is, that means you're going to have an equal sign, which before these two were expressions because there was no equality. But if you see the word is, that means it's equal to. So all of those examples will be equations because they have an equals. So here we've got one number is A more than another number. So here we've got two numbers that we don't know. Let's call one X and one not Y. So I'm going to call this first one Y and this second one X. So that's going to give us Y is twice another number. So 2 times the X. Next, we have one number is A less than twice another number. Here you need to be careful. A less, when you're subtracting, you always subtract from that number. So you're going to have one number, we're going to assign that to Y, is A less than twice another number. So you're going to have 2X minus A. When you subtract, you always need to add that subtraction at the last. If I say 2 less than 20, if you were going to do that, you wouldn't do 2 minus 20 because that would give you negative 18. You would do 20 minus 2, which would be 18. So make sure when you subtract, it's at the end of the equation or expression. Okay, the next one says the product of a number and A decreased by B. So product of a number and A, so X times A decreased by B would be X times A minus B, or you could do AX minus B. It doesn't matter. Multiplication is commutative, so you can switch the order of it. Next, the quotient of a number and the number plus A is 3 times the number. So when you do a quotient, that's division. So if I say the quotient of a number, we'll say X, and the number plus 7, that is the denominator, is 3 times the number. So I've just translated that into an equation. And then the last one is the product of 3 times a number and the number decreased by B is C. That's going to be the product of 3 times a number would be 3X and the number decreased by 3. So since we're doing a product, we're going to multiply that. I'm sorry, and it's decreased by B, not 3. Decreased by B is equal to C. So this is our product part. Our first number was 3 times a number. The second part is the number decreased by B, and then is equal to C. So that's just some practice writing things into a mathematical expression or equation. Let's talk about the steps when you were given a word problem and asked to solve for something. So always identifying the known quantities, assign a variable to the unknowns, draw a picture if possible. This is probably one of my favorite steps. It's amazing if you see a picture of something, how much it is easier to visualize what's going on. So whenever possible, draw a picture. The next is if there's more than one unknown, find a way to write it in terms of the first. So basically get it so you have it in one variable so you can solve. Write an equation and then solve it. So if we look at this first example, it says, find a linear equation to solve for the following unknown quantities. One number exceeds another by 17 and their sum is 31. So let's start with the first part. I'm going to write a linear equation, which means I kind of want it in the form of y equals mx plus b if possible. So if I say one number exceeds another by 17, that tells me that that one number is x plus 17. So x exceeds y by 17. And then the second part is their sum is 31. So that tells me x plus y, my two variables, is equal to 31. So here I've got two equations. The first one uses two variables, but it's already in y equals. So what I can do here is I can use substitution. Since y equals x plus 7, I can take that and plug it into the second equation using substitution to find x first, and then I can use that to find y. So I'm going to use the sum and rewrite y as x plus 17, substituting it in, equals 31. So right here, I've plugged in what y equals to solve, so I have it all in one variable. So you've got 2x plus 17 equals 31. And then you can solve that. I'm going to subtract 17 from both sides. And I've got 2x equals 14. And then when you divide by 2 on both sides, that's going to give you x equals 7. And now you can use that to plug back into either one of the equations. Now that I know what x is, I can say y equals 7 plus 17, which is 24. So my two numbers are 7 and 24. And if you check that, you notice that the sum of those, 7 plus 24, does equal 31. Okay, the next example is very similar. We're going to write a linear equation. This time we've got one number is 3 more than twice another number. So that's going to give you y equals 3 more than means you're going to add 3, but twice another number is going to give you a 2x, and then 3 more will be the plus 3. Here the sum of the numbers is 36. And we're going to do the same process. We're going to use substitution and plug 2x plus 3 in for y. So that gives you x plus 2x plus 3 equals 36. So that'll be 3x plus 3 equals 36. Subtract 3 from both sides. And divide by 3. And then it'll give you x equals 11. And then again, you're going to use that to plug back in the equation. And you can use either one of your equations. The second one here will probably be a little easier to solve, but it doesn't matter. You'll get the same answer. I'm going to subtract 11 from both sides, and that gives me y equals 25. So those are your two numbers. Okay, let's look at the next example. This example says the sum of 3 consecutive odd numbers is 807. Find the numbers. So here, when we're talking about consecutive, consecutive means in a row or right in order. And then the other key word here is they have to be odd numbers. So if I start out with the first number, I don't know what it is, let's call it X. So say if that was 5, if I want the next odd number to get to 7, I would have to skip 6 to get to 7. So I would have to add 2 to get to the next odd number. So not knowing what my number is, I still know the next number has to be 2 more to get to the next consecutive odd number. And then the third number, you're going to do the same process. You're going to add 2 more, or that's just going to be X plus 4. So the sum of these will be X plus 2 plus X plus 4 equals 807. And I can just drop my parentheses because it's addition. So when I combine like terms, I've got 3x plus 6 equals 807. And I'm going to subtract 6 from both sides, which gives me 3x equals 801. And then when you divide that by 3, that'll give you x equals 271. So that's my first odd number. And then the next consecutive odd number would be 2 more than that. Oh, I'm sorry. That's not 271. I was jumping ahead. That's actually 267. So my first odd number is 267, which means the next one would be 2 more, 269, and then the next one would be 271. So those are my 3 numbers, and then to check that, if you added them up, they will be 807. So that just makes sure, check your answer and make sure it comes out to be what you set your equation up to be. Okay, in the next example, we're talking about cell phone companies. You've got a company A and a company B. Company A, the plan has a cost of $34 plus 5 cents per minute. And then company B has a service fee of $40.04 a minute. So if I want to write a linear equation for both companies, and we're going to let C be the total cost, company A is going to be the cost equals 34 plus 5 cents per minute. So we're going to use the X to represent the number of minutes. And then, of course, if you want to keep it in Y equals MX plus B, you would just flip that around. But either one of those is acceptable. You can put it in MX plus B, or you can just leave it in the order that you started with. And then company B will be similar, but it's 40 plus 0.04x. And then again, if you want to flip that around, it's 0.04x plus 40. So those are your 2 equations for each company. The next question, or the next part, asks you which one offers a better plan for 1160 minutes. So to find that out, you're just going to simply plug this in for X, your number of minutes. So let's look at company A. If I plug that in for the cost, I've got 0.05 times 1160 plus 34. And when you work that out, you're going to get $92 is your cost with Company A. Company B, we're going to do the same thing, but use its equation. So we're going to have the cost is 0.04x plus 40. And we're going to plug in $11.60 for x. So the cost here is going to be $86.40. So in this case, Company B using 1160 minutes is going to be the better deal. Okay, the last part of this question is how many minutes would yield equal monthly statements from both companies? The key word there is equal. You have two equations that give you the cost. You're going to set those equal to each other. So I'm going to have 0.05x plus 34, and I'm going to set it equal to 0.04x plus 40. And that will give me where those two intersect or are equal monthly statements. So solving here, I'm going to subtract 0.04 from both sides. And then at the same time, I'm going to subtract 34 from both sides. So what that will leave me with is 0.01x equals 6. And then when I divide by 0.01, that's going to move my decimal 2 places. So x is going to equal 600. So at 600 minutes, the two cell phone companies cost the same. So you're also going to have some word problems that use some common formulas. So let's just review some of those formulas. You are expected to know these. So for area of a rectangle, area is length times width. For a triangle, it's 1/2 base times height, or you might have seen it as base times height divided by 2. They're the same thing. Area of a circle is pi r squared. Perimeter, which is all the way around. For a rectangle, remember you would add up all the sides. So you could have width plus length plus length, or that is the same as 2w plus 2l. Now, perimeter of a circle is actually the circumference of a circle, which is 2 pi r. Don't confuse that with area of a circle, which is pi r squared. Area is the squared one. Remember square units. Perimeter is just feet or inches or the one-dimensional, so it's 2 pi r. When you go into volume, a rectangular prism is length times width times height, which notice length times width is your area of the base, and then you multiply it by the height. Same thing for a cylinder. Has a circular base, so it's going to be the area of the base, pi r squared, times the height. And then the last formula is the distance formula, and I'm not talking about the square root one we learned in the first section. This is distance equals rate times time, where r is your rate and t is your time. So those are a few formulas just to be familiar with, and we're going to use those on the next few examples. First example, the perimeter of a rectangular outdoor patio is 54 feet. The length is 3 feet greater than the width. what are the dimensions of the patio? So here, draw a picture and label everything you know. I know the perimeter is 54 feet. And they also tell me that the length is 3 feet greater than the width. So if these are the widths of the rectangle, then my length is 3 feet greater than the width. So that'll be W plus 3. And the reason why I will need that is so I can write an equation all in one variable. So if I'm going to find my dimensions, I'm going to find my width first, which if you add up all the sides, we know that that equals 54. That's your perimeter. Combining like terms, I've got 1, 2, 3, 4 W plus 6 equals 54. I'm going to subtract 6 from both sides. And then divide by 4, which gives me a width that equals 12. So if my width equals 12, then my length is W plus 3, which will be 12 plus 3 is 15. So the dimensions of the patio will be a 12 by 15 patio, where 12 is my width and 15 is my length. Okay, on the next example, we're going to use another formula, and we're going to actually use the volume of a rectangular prism because we're dealing with a box. So it says find the dimensions of a shipping box given that the length is twice the width, the height is 8 inches, and the volume is 1600 inches. So draw the best box you can. Not too bad. I know that the height is 8 inches. I know my volume is 1600. And I know that the length is twice the width. So if my width is here, my length is 2 times W. So since I'm dealing with volume, I'm going to use the volume of a rectangular prism. So I've got length, which we're going to put in terms of W, 2W, times width, times height is 8. That equals my volume, which we know is 1600. So when you multiply that all together, 2 times 8 is 16, and W times W is W squared, equals 1600. You're going to divide both sides by 16, which gives you W squared equals 100. And then to get rid of that squared, I need to square root both sides. If you square root a square, it just gives you back what's underneath. So that gives me W equals, it actually gives me plus or minus 10, but I'm talking about the length of a side, so that's always going to be positive. So you're going to have W equals 10, which our length is 2 times the width, so that'll be 20. So the dimensions of our box are 10 by 20 by 8. So if you can just draw a picture, find a formula that you know can be used, and label everything and set up an equation. These aren't hard equations to solve. It's just getting started that might be a little tricky. And that is the case for this last example. Marcus drove home from college traveling at an average speed of 68.2 miles per hour and drove back to the college the following week at an average speed of 65.1 miles per hour. If the total round trip took 10 hours, how much time did it take Lucas to drive from home back to college? Express the time in hours and minutes, round to the nearest minute. So there's a lot going on in this example, so it really helps here if you just draw a simple sketch. I'm going to say this is college and this is home. It's probably not a straight shot, but I'm going to just draw it like it is. And they tell me that Marcus drove home from college, so this direction, at a rate of 68.2 miles per hour. And then his return trip to college was 65.1 miles per hour. They also told me that the round trip took 10 hours. So I don't know how long it took him to go from college to home. I'm just going to say it took T hours. But if the entire trip took 10 hours, then on his way back, you're going to have 10 minus the time that it took to get there. So those are your two times that you're going to use. That's key there. One, if you don't know the first time, but you know the total, you're just going to subtract the unknown from 10. So here, the formula we're going to use, we're dealing with speed and time. That should be a hint that you're going to use your distance, which is rate times time. Your speed is your rate, and your time is our variable that we're dealing with. So let's write an equation for the first one, from the college to home. The distance is his rate, which was 68.2 times t. And then back to college, his distance would be the rate, 65.1, times his time would be 10 minus t. I hope that makes sense. So where I got the 10 minus t from, I took the time off from the 10 hours that it took him to get home because it was the round trip time. Okay, now I need to solve for t. So I've got two equations that are my distance. We know the distance is the same from college to home, no matter which direction you go. So I'm going to set those equal to each other and solve for t. So here I've got 68.2t equals, I'm going to distribute the 65.1. So 65.1 times 10 will give me 651. And then minus 65.1t. Then I'm going to add 65.1 to get my t's on one side. And that will give me 133.3 t equals 651. And then when you divide, you're going to end up with t equals 4.88, and that's hours. Now here's where you got to be careful. Did we answer the question? This is t up here, but our question is asking how much time did it take Lucas to drive from home back to the college? So we're wanting this amount of time. So you're going to take, to go back to college, you're going to have 10 minus your t, which is 4.88. And when you subtract that, you get 5.12. Now, one more thing, and we're almost done. They want you to round to the nearest minute. So we've got 5 hours, but our .12 we need to turn into minutes. So to do that, you're going to do .12 times 60, because there's 60 minutes in an hour, which is going to give you 7.2. So to the nearest minute would be 7 minutes. So the return trip took him 5 hours and 7 minutes. So as you're doing your homework, I don't want you to get scared of word problems. Just break them down, draw a picture if you can, label everything, and then set up an equation in one variable that you can solve.